Hi, I'm Arshi. In this video, we are going to learn about a very special geometric quantity called volume. Specifically, we are going to learn what volume is, what are its units, and how do we calculate the volume of few simple solids. To understand this, let's begin with a story. Sam wants to fill his fish tank completely with water, but he is not sure that how much water he will need. Sarah wants to fill her can completely with lemonade. Both Sam and Sarah will get answer to their questions if they understand the concept of volume. So, volume of an object is the space occupied by that object in 3 dimensions. But before we delve into the concept of volume, we need to relook on the previously learned concept starting from 1 dimension, like a line segment. A line segment is a one-dimensional quantity which has got length as 1 dimension, and it is measured in centimeter or meter. Now, if I take this line segment and extend it in a certain direction at a certain distance perpendicular to its length, we obtain a 2-dimensional quantity called rectangle. Now, length and width are the 2 dimensions of this 2-dimensional quantity rectangle, and the space occupied by this rectangle is called its area, and the unit for area is centimeter squared or meter squared. Now, let's see how do we obtain 3-dimensional shapes. There are many 3-dimensional shapes which are obtained by taking a 2-dimensional shape and extending it along the 3rd dimension. Let's see how. If we take a rectangle and extend it along the 3rd dimension, we obtain a rectangular prism. If we take a triangle and extend it along the 3rd dimension, we obtain a triangular prism. And if we take a circle and extend it along the 3rd dimension, we obtain a cylinder. So, in this way, we obtain the 3-dimensional objects, and the volume is the space occupied by these 3-dimensional objects. Now, the interesting thing about the volume is we have a general formula to calculate the volume of these solids. All we need to do is find the area of the 2D shape which was extended and multiply it with the distance it got extended. Usually, the 2D shape which was extended is called the base of the 3-dimensional object, and the distance it was extended is called the height of the 2-dimensional object. Therefore, the volume of a solid is base times height. Now, let's calculate the volume of rectangular prism. Now, let's see how do we get the volume of a rectangular prism. The base of the rectangular prism is a rectangle whose area is length times width, and the distance this rectangle got extended is the height of the rectangular prism. Therefore, the volume of the rectangular prism is length times width times height. Therefore, the volume of the rectangular prism is length times width times height, and the unit for calculating the volume is centimeter cubed or meter cubed. Now, let's find out the volume of cylinder. Since the base of the cylinder is circle, so the area of the circle is pi r squared, and the distance it got extended is the height of the cylinder. Therefore, the volume of the cylinder is pi times r squared times height, and the unit for this is centimeter cubed or meter cubed. Now, in this way we can find out the volume of many other 3D shapes, like we can find the volume of the triangular prism, the trapezoidal prism, etc. But all 3D shapes are not obtained by taking a 2D shape and extending it along the third dimension. There are few 3D objects which are obtained by taking a 2D shape and rotating it along one of its axes. Let's see how. If we take a circle and rotate it along its diameter, we obtain a sphere. So, in this way, let's see how do we get a cone. If we take a right triangle and rotate it along one of its perpendicular sides, we obtain a cone. Now, let's find out how do we get the volume of a cone. To calculate the volume of the cone, we need to compare it with that of the cylinder of same base radius and same height. For this purpose, we need to take a hollow cone and a hollow cylinder, but we need to ensure that the radius of cylinder and the cone and the height of the cylinder and the cone should be same. Let's start filling the cone with water and pour the water into the cylinder. Let's repeat this activity for the second time. Fill the cone with water and pour it into the cylinder. We saw the cylinder is still not completely filled, so let's repeat it for the third time and fill it with the cylinder. Now we saw that the cylinder got filled in 3 rounds, and we already know the volume of the cylinder is pi r squared h, and since it took 3 rounds for the cone to fill the cylinder, the volume of the cone will be 1/3 of the volume of the cylinder, that is 1/3 of pi r squared h. This is how we can calculate the volume of a cone. Now, let's apply this knowledge to few daily life examples. Now, we have a question where we have a soft drink which is available in 2 packs. First, a tin can with a rectangular base of length 5 cm and width 4 cm and height of 15 cm. And the second one is a plastic cylinder with circular base of diameter 7 cm and height 10 cm. Which container has greater capacity and by how much? In order to compare the capacities of 2 different shaped cans, we need to find the volume of the can with rectangular base and the can with the circular base. Now, the first case, since the can has the rectangular base, it is in the shape of a rectangular prism. So, the length is 5 cm and width is 4 cm. The width is 4 cm and height is 15 cm. Now we know that volume of rectangular prism is length times width times height. Therefore, 5 times 4 times 15, which is equal to 300 centimeter cubed. Now let's find out the volume of the cylindrical can. It's in the shape of the cylinder. Whose diameter is 7 centimeter. So base radius is 7/2. Since diameter is 7 centimeter, radius is going to be 7/2 centimeter. Therefore, volume of cylinder is pi r squared h. So, taking the approximate value of pi, which is 22 on 7 times 7 on 2 times 7 on 2 times height. This is the height of the cylinder. After calculating, we got 385 centimeter cubed as the volume of cylindrical can. In order to compare them, let's find their difference. Difference is 385 minus 300, which is 85 centimeter cubed. Hence, we can conclude that the plastic cylinder has the greater capacity by 85 centimeter cube. Now, let's take up one more question based on the volume of cone. Now, let's find out the volume of a conical vessel whose with height 12 centimeter and base radius 5 centimeter. Let's draw a cone whose height is 12 centimeter and radius is 5 centimeter. So, since we know the volume of cone is 1/3 of pi r squared h, we get 1/3 of 3.14 times 5 times 10. Sorry, it's 12. It is 12. So, after calculating 314 cubic centimeter, we got the volume of this conical vessel. So, alright, in this lesson we have learned what volume is, what are its units. We have also learned how 3D objects are formed, and we have learned how to calculate the volume of few simple solids. Thank you.